my PhD is involved with understanding a technique called froth flotation. This is a way of separating valuable minerals from waste minerals using bubbles, which sounds really fun. And it's pretty fun, it's pretty messy, so I spent a large portion of my PhD doing lab work. One of the reasons that I've been doing this research is that the process has been used for well over a century now, but it's really super inefficient. So we're looking at how can we make it more efficient and therefore more sustainable. So we need metals in our everyday life. We use so much electricity, we need a huge amount of copper. But because we're extracting copper by this really inefficient process, we're looking at ways of making it more efficient, primarily by being able to increase the particle size needed for this process, which means we waste less energy on grinding. Grinding is a huge energy waste at the moment. Something like 6% of the world's electrical energy, which is equivalent to the amount of energy that Germany uses in a year, is used to grind rocks globally, which is crazy in my book. So my PhD has been focusing on ways to reduce this energy consumption by not needing as fine particles for the process. And one of the ways that I've been understanding this is using a technique called positron emission particle tracking, which is essentially using a medical PET camera. The piece of kit that I use has actually used to be used in a hospital, and now we use it in a lab in Cape Town, where we insert a radioactive particle into the cell that we're using, and we can track this particle through space and time, and then we can get an understanding of how particles within the system are flowing. And this can then be used in the future to better understand the systems, to improve the models that we have, because at the moment there's lots of models of froth flotation, but it's hard to get experimental evidence necessarily to back that up because it's an opaque system. So we can't see what's going on in the middle unless we use this technique that I've been using in my PhD. So we've been looking at how we can actually completely understand what's going on inside the cell, which I think is super cool, and I've really enjoyed it. So. I think I would tell myself, you've got this, keep going, and don't be afraid to ask for help.